One of the most important things when we do any type of mathematical modeling is how we communicate the results that we found. And so what we're going to start with in this lesson is visualization. How do we visualize the actions that we see on a football pitch? I like to motivate this a little bit. I mean, my background wasn't initially in modeling mathematics of football. I worked originally in biology and sociology and creating mathematical models. And what I learned there is you have to be very clear with the people that you work with how your models work, and you have to be able to communicate about them. And a lot of the time that comes down to drawing pictures which illustrate the workings of your model. Now, I took this quote from Socomatics, which I thought might be quite nice to start with. And exactly as I said, one thing I have learned from my work in biology and sociology is that in order for the message I want to come across and to be understood, it must be straightforward. It's the job of the mathematician, that's you and that's me, to take a lot of complex data and boil it down to a simple but powerful idea. And that's a general thing that we see everywhere in mathematical modeling. Mathematical modeling isn't just about sort of collecting up masses and masses of data. It's about taking that data, boiling it down to a simple idea which can be communicated by the people who are interested in that data. So in football, the message needs to be even more direct. In the dressing room at halftime, with a team behind by 2 goals and unable to keep control of the ball, the manager has to be able to convey a plan quickly. I tried to imagine what I would do in that situation. The manager is lost for ideas, and in a final act of desperation, he turns to me or to you, the mathematician, and he asks, "Can you see the problem?" Now, it often isn't the case that you need to be able to communicate ideas at halftime when you're working with modeling at a football club, because that is one of the times that you're most time limited. But to have that idea in the back of your head that you want to be able to communicate what you found out quickly, concisely, and visually in a way that players will understand, in the way that coaches will understand, in a way that the sporting director can understand, in the way that the board members can understand, and also in the way that fans can understand. That is key to any type of mathematical modeling. And we're going to start today with a few simple examples of that. Let's start with pass and shot maps, and that on the next page, if you look on the web page, is what you're going to learn how to plot in Python. But I'm going to start with an example, and this was one of the first examples that I got interested in. This is the Euros 2012. This was one of the first times that I analyzed any football data. And what's shown here is Italy versus Germany. And what we're going to look at in a bit is a pass map, so how the players pass to each other. So watch the sequence of passes carefully. You'll see in a minute the ball is going to go to Pirlo here. He's trying to advance the ball and find a way to attack. And you see he sort of nonchalantly walks back to the halfway line, and then he launches a lovely ball out to the wing, which once received, a couple of passes into the box, and it's a goal. Mario Balotelli. So it's a lovely goal. And of course, we're always, when we look at football, we're always interested in the sort of final action of the goal. But what's very nice about this example, I think, is the sequence of build-up passes around about the midfield, which Italy have, before they launch their attack. And to illustrate this, let's look carefully at the passes. What we've got here is the actual plot of the passes. So the lighter the pass, the further back in time that particular pass occurred. So this was the first pass, second pass, third pass, fourth pass, fifth pass to Pirlo. Pirlo walks back, and then he makes a long pass out to the wing. Let's just look again at those sequences. This is these passes around in the middle of the pitch there. And then if we move on one more step, we can see the pass that goes back to Pirlo. This is the pass, and we're now going to see the pass that's marked B to C on the plot, where he launches the ball out to the wing. There we go. And so really all we're doing is we're plotting the XY coordinates of the start of the pass and the XY coordinates of the end of the pass. And then we have the pass out at the wing, preceded by, or followed by a dribble, and then the pass in to Balotelli for the goal. So we can do this not just for, I plotted these passes by hand. I just followed the coordinates on the pitch, marked them and collected the data. But what now large data collection companies do is that they have somebody in the ground who collects every one of those passes, often live during the matches, and keeps a record of all the passes that have been made. They also keep a record of dribbles, interceptions, tackles. Everything that happens on the ball can be recorded in this way with the XY positions on the pitch. We can also, another type of data we're going to look at, we're going to come back to this a bit later in the course, but it's worth just mentioning it just now, is tracking data. And in this piece, so here was a sequence of passes, and what I've plotted here, starting with a lighter color up to the darker color, is following the position of Mesut Ozil as he's running. Oops, I can do this here. So Ozil is here, he goes up in challenges, and then he sort of starts to wander off, gets closer and closer. And you can see that he gets drawn into Pirlo, and it's him who challenges Pirlo before he goes back. And what's happened is he's been drawn in from the right-hand side, where the ball is eventually going to go to, and we can actually follow his track in this way. And so this is what we would call off-the-ball data, and we're going to come back to the analysis of this. I think the point I want to illustrate in this example is that they've been drawn up maybe with one more player in press up here than they might have wanted to have given the particular situation. So the passes around here have a role of drawing in the Germany players, and then once there's some space opened up, Pirlo takes a long pass past them. And one or two actions in a particular football match, well, that tells you something about that particular situation, and you can think about that. But often when we're analyzing data where we have lots and lots of passes, this next example is now based on, this is no longer me collecting the data, this is now based on a company collecting the data. And what we've done here is we've plotted the most valuable passes of Trent Alexander-Arnold, the Liverpool right back. I think this was the 2019-20 season. And in that season, and in general, he specializes in this very clear type of pass where he has the ball on the right wing. He often steps into this area here, and then he passes out to the left wing, often to Sadio Mane or to Andrew Robertson, who's playing on the left back. And then Andrew Robertson's most valuable passes, well, they find their way in, again, from this kind of middle half space area here into the box. And this was a very specific style of play that Liverpool played that season, which we can see very clearly just by plotting the most. We're going to come back to how I say the most valuable passes, or what the most valuable passes are later. But we can actually see quite clearly that those types of passes were the ones that led to goal. And by plotting them, we can really get an idea about the style of play that Liverpool had that season, both by moving the ball over to the left-hand side, often by confusing it moving back to the right, where Salah would come in and score a lot of goals from there. So that's pass maps. Another type of map we can make is, of course, shots. This black and white diagram here is a very simple type of shot map. Basically, what I've done is I've made a black dot for every shot that the player has made. And this is from the 2014-15 season in the Champions League. So every shot in the Champions League by these three strikers for Real Madrid: Ronaldo, Benzema, and Bale. And just this, I think, like the Trent Alexander-Arnold plot and the Andrew Robertson plot, we can already see a sort of style of shooting. And there's, oh yes, I forgot to say, there's one extra thing, is that if there's a ring round this is a goal. So these are the goals Ronaldo scored, goals Benzema scored, the goals that Bale scored. And so we can definitely see a style of shooting. So Ronaldo, a lot of shots. And I often come back to this with Ronaldo. You see a lot of clips with him scoring from distance very successfully. In this Champions League season, he had over 30 shots from outside of the box. Not one of them was a goal. And very clearly, there is an advantage to shooting closer to the goal. I suppose this should really come as no surprise, but we see that Ronaldo's goals do typically come from this area inside the box. And in particular, Benzema, who is a fantastic finisher, has, almost half of his shots from this sort of golden area here in a circle near to the goal result in a goal. So he has 1, 2, 3, 4, 5, 6 goals at this particular point. Bale, long distance shots from further out on the right, but clusters of shots inside the box. And so we see a clear difference. We see actually clearly that Ronaldo is the one who is allowed to shoot from distance for the Real Madrid side. Benzema has a role he's a striker right in front of the goal. We can change those types of, again, I've taken a Liverpool example, and this is Mohamed Salah, Sadio Mane, and Firmino in exactly the same season. What I really wanted to illustrate here, and this is a general pattern that has some of it has come actually from the use of analytics and numbers in football, is that modern strikers tend to take most of their shots from this circle in the center of the goal. So this is from 10 matches. The stars are goals, the red are shots on target, and green are shots on target, and red are blocked or saved. And you see that all three of these players, all of their shots come from this circle round the goal. Mane's more on the left. Salah in this case is kind of central. Firmino is also central. They don't take those types of long distance shots, mainly because they very seldom result in a goal. The whole idea is to get the ball into this circle where you've got a good chance of scoring. This is another example. This is, we're going to come back to expected goals as well, which is kind of a measure of the quality, but it's a measure of how near to the goal that you've got and how good shooting angle you have. And this is from England's match against Norway. I took this example because it's one of the highest expected goals matches. It was certainly in that tournament, it was the highest expected goals match. We see, again, a cluster of the goals are the good opportunities where you get into this circle here. And Norway had one good opportunity in this particular match. Okay, so that is the basic idea of plotting actions on the pitch. We've looked here at shots and we've looked at passes. You shouldn't forget also, and much of what you'll be working with is also looking at defensive actions, so tackles, interceptions, defensive headers. Those types of actions can also be plotted in the same way. In the StatsBomb and Wyscout data, there's a special category for those particular actions. But I'm going to move on now to another very nice way of visualizing data, and that is passing networks. So this allows us to see which players are connecting with each other. Again, I'm going to start with the Euro 2012. And I think these examples are still, they're old, but they're still very illustrative of a nice approach to this thing. Again, Pirlo is in the center here. And this is a passing network which shows the links between pairs of players who completed 13 or more passes between them during the match. So that's quite a high threshold for plotting passes. But this match was played over 120 minutes. And what I really want to illustrate here is that Italy did have a lot of possession of the ball and a lot of passing connections. And I like to think of Pirlo as a kind of center of this wheel where the ball was rotating round and round before they launched attacks. England, on the other hand, the only two players who completed more than 13 passes was Hart to Carroll. And Carroll came on, I think, in the sort of 60th minute of the match. So he only played for 60 minutes. But what was happening is that Italy were mounting various attacks. In the end, these attacks were cancelled out in various ways. And Hart would then send the ball up directly to Carroll, who would try to score. And that was, for the last 60 minutes, pretty much England's tactic. So the point here is that we can visualize the pattern of the game very clearly using these passing networks. We can sort of capture the essence of the game. Oh yes, one thing I wanted to mention here is written, both teams are attacking left to right. And that's been true of most of the plots I've made. So whenever I plot a team, I plot the attacking actions left to right. I think it was, yes, so I did the same here. Even though the action was going from the right to the left, I actually plotted left to right. And that's just a standard, really, and there's no particular reason for it, but that's just become a standard for football analytics. Those shots were plotted left to right as well. Of course, if you've got two teams, then you want to plot them in both directions. So there is some variations of that, but a kind of, unless otherwise stated, we're always attacking left to right. So even England and Italy are playing each other, we plot them both attacking left to right. This is another example, and this is related to one of the case studies we look at further in the notes, and this is to do with centralized football. And this is a study done by Devin Ployler, where he looked at the passing networks for the women's US national team. And what he spotted was a very clear link all the time to Van Back, a little bit like the one we saw up to Andy Carroll. And he identified that this was a problem for the US women's national team, that they depended a little bit too much on Wambach and kept sending the ball up to her. And what's been found in studies of football is a decentralized attack is better. And decentralized means that you pass the ball around lots of different players. And you can see in this was a match where I think they won it, but they weren't playing particularly well. Then they were playing a lot better when Wambach was not selected for this particular game. And then you started to see a more decentralized pattern. It wasn't that the ball was always going to one of the particular players. These passing networks are something that I've used in my work with Hammarby. And in this case, the passing networks, we're interested in Sirius, which is the opposition that we're going to meet. And here I've broken my own rule about left to right. And the reason I've broken the rule for left to right is that in this, when the trainers are comparing the video to the passing network, Sirius were attacking right to left in this particular video. So we've done it in the direction of the video. So you need to really tune these things to the particular application that you're doing. But what we can see here is how Sirius build up in the first, when they're in the first third, they don't really pass so much. They move the ball quite rapidly into the middle third. And there you see the very important players in the build up. Here's number 6, who's Hjalmar Ekdal, lots of the ball coming into him. And Tim Björkström, who's number 8, the ball is going through him. So there's a lot of build up between the backs. And then there's a very rapid attack in the final third with fewer passes. And so it's here that here in the middle third that Sirius rotate the ball most. And you can identify which of the players are most central to that particular type of build-up. The breaking into the middle third really is because you often talk about 3 stages of build-up. You talk about the initial build-up, you talk about middle third build-up, and then you talk about, well, it's no longer build-up, but the attacking football that you play in the final third. Another example of this is from the recent Euro 2022. This is a bit actually like the Andy Carroll example again, but I thought this was really beautiful and clear. The ball doesn't just come from the goalkeeper up to Pernilla Harder. The ball comes from pretty much all of the players. This is a game where Denmark were playing against Spain. Spain are a heavy possession team. Denmark know that in advance. And they came with a very clear strategy to this game, that they were going to get the ball to Harder, and Harder then run in with further players who would try and score from there. And they didn't win in the end. They lost 1-0, but they came very close to scoring through this strategy. So it's not that it's not that always this kind of lovely decentralized networks are the best way of playing. There are ways in which you can focus on particular players and play successful football in this way. And these passing networks quite successfully capture these. I took another final example, and this is an example I took from Maram Al-Baharna, who works for The Athletic, and she's done a film for the Friends of Tracking. I've linked that also on the web pages. And she was looking at the different playing styles of Arsenal over the years against Leicester. So she was interested in the passing networks which Arsenal have been using over the past few seasons. And Arsenal have, it's interesting, these videos will of course date, but 4 weeks into the season where I'm currently making this, the 2022-23 season, Arsenal are top of the league after 4 games. And it really seems that their playing style is coming together, that they're managing to move further up the pitch with their passing networks and start to dominate matches in a way that they haven't been able to do in earlier seasons. And Maram, I really recommend her articles. You can go in and she uses all types of visualizations very clearly to show these types of development of the team, which players are the most important and so on. Good, so that's passing networks. The last one, the last part of visualization that we're going to look at is heat maps. And the reason we want to look at heat maps is we want to summarize lots of events. If you start to think about those shot maps that I looked at, for example, especially the Liverpool one, it started to get very cluttered. There was like loads and loads of different shots there, and it was a little bit hard to see what the pattern is. What heat maps allow you to do is see a pattern. And a heat map really is a 2-dimensional histogram. So if you're familiar with the idea of plotting a histogram of events, which sort of summarize them, then the heat map is a 2-dimensional histogram placed on the football pitch. This was going to go back to Euro 2012 and the Germany versus Italy match. And I think what I wanted to illustrate here, and this maybe isn't enough data to make a very convincing heat map. But when I started this, I was sort of collecting my own data on Euro 2012, for example. And what I did is I plotted where Pirlo's passes come from as a heat map here. And you can see that the passes originate most often pretty much in this area we saw the pass earlier from, around about here. And if he's on the left-hand side of the pitch, the passes tend to go to the right-hand side. If he's further over the right, then exactly as we saw, the passes tend to go over to the left-hand side. So he switches the direction of the play. What we see, what we can compare, and this kind of gets the sort of personality of the players or the sort of style of play of the players. If we can compare it with Schweinsteiger, he's everywhere. So while Pirlo is very centralized in the middle, Schweinsteiger, who's essentially playing in pretty much the same kind of central midfield role, is moving everywhere over the pitch. He's passing from his own half, he's out on the right wing, he's out on the left wing, he's in the box making small passes. And this heat map manages to capture the difference between the two. As I said, there might be, it could be argued that there isn't really enough data to make heat map, and we're going to come back to examples where we have a little bit more data soon. But before I do that, I want to show you a heat map that I'm not very keen on. And this is the following heat map. This is Ronaldo again. What's wrong with this heat map is that this kind of smudging out, which maybe makes it look good or look kind of more scientific, is also unrealistic. It isn't necessarily the case that he made passes from these different things, these different places. So he might have made one pass here where there's a kind of yellow. It really doesn't give you an honest idea of what was going on. It's very difficult to interpret exactly what it means with these very high intensity red areas and very low intensity yellow areas. So I don't like the smoothing on it. That's one problem with it. The other thing that's problematic about it is there really isn't any context to it. So when we're looking at midfield players, as we were looking at Schweinsteiger and Pirlo, then nearly everything they do is part of a build-up of an attack. But when we look at Ronaldo, his job is to get the ball into the box, or if he has the ball in the box, his job is to score. So many of the touches that he makes out here, for example, are not really relevant to his role as an attacking player. And when I made a heat map of Ronaldo, so this is what I want to say, context is important. And so I made a heat map of Ronaldo. Oh, did I? Yeah, here's Ronaldo's heat map. This isn't actually a heat map of Ronaldo. This is now a heat map of every one of the passes made in the Champions League by Real Madrid within 15 seconds of a shot. So every time they had a shot, I go back in time and I look to see where was the ball touched leading up to that shot. And that actually tells you where are the important attacking moments for Real Madrid. And then we can see, I mean, the overall picture, I suppose, isn't very different from the single heat map we saw of Ronaldo. But what we see is now we have the context to show that Real Madrid are most dangerous in exactly this area where Ronaldo and Marcelo were playing at this time. They're also, of course, dangerous right in front of the goal, but they're more dangerous out on the left wing than they are on the right wing. So there might be quite a lot of touches of the ball out on the right wing, but the dangerous touches of the ball, the ones that within 15 seconds will lead to a goal, are out on the left wing. There's more examples which you can look on the web page. This is one I made of Mesut Ozil. I was complaining about his sort of getting drawn in defensively earlier, but what Ozil was well, he still is a player, but he's a player which statistics really loved because he always progressed the ball forward. And I think he may well have been signed by Arsenal on the basis of statistics. When you looked at his heat map of where he was passing the ball, it was all over this area in front of the goal, and the ball, the arrows show, was on average always going forward. And so he was always progressing the ball forward whenever he managed to get it. And so the statistics showed that he was a fantastic player. And I'm sure he still is a fantastic player. Okay, we're going to look at a heat map. We'll come back to this in the next lecture, but this is a heat map of the number of shots taken from different areas. And this is now over an entire season of Premier League football, 2017-2018. You can see the bar here from 0 shots taken from various places up to 50 shots that are taken in various places. And this shows you, well, there's quite a lot of shooting that goes on from outside the box. It isn't as if all the shots are central. But we can compare this to goals scored. So number of goals scored, if we look at a heat map of that, very intensely, those ones that are inside the box. Number of shots made, very intensely all over this larger area. And this gives a clear picture of something we're going to come back to quite a few times. Shooting nearer to the goal has a massive difference in the probability of scoring. It might look fantastic to score from distance, but it is those shots that typically end up being scored as goals. Now, I have been a bit neglected in not mentioning so many defensive actions. This is one time which I am going to plot some of these things. So this was a plot I made looking at just for a couple of matches, actually. This was when Klopp took over as Liverpool manager. Could we already see some difference in how they were defending? And Klopp is well known for his pressing style, that the team have to press and get the ball back. And this were before Klopp took over. You can see the defense is more over here. I've made a heat map of the lines here, and the dots are where the actual defensive actions would occur. And when Klopp took over, you can see that this is moving forward, both in the intensity here in the middle of the pitch, but also they're starting to make more tackles or more defensive actions further up the pitch. So you can start to see already after a couple of matches that, well, the hypothesis that Klopp presses more and takes the ball back further up the pitch seems to hold. I wouldn't say that it's 100% certain, but it seemed to be holding at that point. And this is another way of doing this. So this is now defensive actions. Oh, this is defensive actions, and what's done here, I think, yeah, I'll just say a few words about this because we're going to come back to this a bit later, but I'll say a few words now. That often when you're making these types of maps, you want to normalize in some way. And normalize means you want to correct for the, you might want to correct for the amount of time that they've taken place. You might want to correct, as in this case, for the number of opposition passes. So when you look at defensive actions, if a team is just always defending and they never pass the ball and they never have possession, then they'll come up as very, very red, as if they're defending everywhere over the pitch very well. So you'll actually have the worst teams who never do anything good will be the ones that have the most intense color for always defending. So what you do, and what they've done in this image from StatsBomb, is that they've corrected and normalized for the number of opposition passes. So this means if the opposite, you take the defensive actions, you divide it by the number of opposition passes, and that corrects for the fact that the opposition have got the ball when you're doing these defensive actions. To cut a long story short, they illustrate here very nicely, and if you can read the article later, they illustrate very nicely how Leeds United were intensely pressing and doing a lot more defensive actions than any other team. The other team, and they actually did very well the season afterwards, who were good on this, were Barnsley. But both of these teams were adopting a very high pressing game that when the opposition were passing, they were doing a lot of defensive actions. And of course, Leeds were successful, so they actually have possession quite a lot. So this correction would lift out that they're not only playing well, but they're not only attacking well, but they're also defending well. Now, we're getting a little bit into this at the end. So we've started off by just looking at individual actions. We've then started to look at these networks of connections. Then I've gone over to passing, then I've gone over to heat maps, which show how a player is performing over 10 games or how a team is performing over 10 games. And when we're working inside clubs, we want to boil these things down often to a single number or a single visualization, or often a sort of combination of the visualization and the number. And within the club, these are called key performance indices. And how can a club monitor performance using these key performance indices? So I want to close with this is one example that we used at Hammarby. This was an example where we could actually see our KPI, key performance index, was very poor. We had a strategy that we wanted to, whenever we lost the ball in the opponent's, in our final third, in the opponent's defensive third, we wanted to win it all back quickly. That was a goal for the coaches. And this number here is the proportion of time that we won the ball back within 5 seconds of losing it in each of these zones. And this 10% is not good, right? Of course, you can't expect to win it back all the time. The top level around for this KPI is about sort of 20-25% Manchester City, and maybe between those two levels. But 10% was not what we wanted to do. And so this was presented for the coach, and that was something that over the next 10 weeks or so, that number increased, and the players worked very hard to improve the way that they won back the ball. It doesn't tell you the solution, but it does tell you part of the problem by looking at any particular KPI. Also notice, like I mean, you can have KPIs like goals scored and things like that, place you are in the league, all of these types of things. They're good for telling you how well you're doing, but I think everyone knows how well you're doing. These tell you things about what you need to improve. What specific thing that you had as an aim do you need to improve? Here's a list of various ones that you can have. Entries into the final third box, shots in the danger zone, that's a circle around the box. You can think about like number of passes leading to a shot. Do you play, if your aim is to play a possession-based game, how many passes do you make leading up to a shot? Again, that doesn't mean these first two are really highly correlated with winning games. This one is more about your style of play. Ball recoveries within 5 seconds, that's also about your style of play. It's possible to play football without that idea of recovering the ball quickly. Passing tempo is another one. How fast are you moving the ball? That is correlated with success, but some teams want to play with a high tempo. Some teams want to play all the time with a high tempo. Other teams want to play some of the time with a high tempo. So that's something you can measure. Expected goals, that's very correlated with shots in the danger zone, but that's another one that you can have. We'll come back to expected goals later. And the idea here is that you have a single set of measures that are used over the entire club. So everyone's agreed with these things. Maybe the players don't need to be so aware of these particular measurements, but the coaches need to be, the board can also be aware of these types of measurements. Everybody can be sort of on the same page about what we're trying to achieve. And we might not only just be trying to achieve, in fact, I haven't got position in the table here, for example. We might be trying to achieve something about our style of play as much as we are trying to achieve actually, well, winning the matches. Few examples to close, and these are on the webpage, so you can have a look at them. This is expected goals over time. I've taken them from Liverpool at the end of the last season, the 2021-22 season. These are expected goals. You probably can't read the number down here, but they've got, over those 10 matches, they've got 20.3 expected goals. So 2 expected goals per match, pretty good. They scored 19 real goals. So those kind of line up. They were neither unlucky or lucky. And you can see over the matches, apart from their game against Manchester City, they won all of their matches on expected goal difference. This is opposition's expected goals. This is Liverpool's expected goals. They won these matches on expected goals, as well as I think they draw the City match. So this shows that they had an overall high performance on that particular metric. This is now getting more into the nitty-gritty detail of this. This is the transition map. What is shown here is, so this is when Liverpool are attacking. This is when Liverpool are defending. In both cases, Liverpool are attacking left to right. But this shows when they win the ball back in various types of various parts of the pitch, what is the danger, what is the expected goal that results from them winning the ball back. So a star means they won the ball back and they scored a goal, but all these circles show how dangerous a chance they created when they won the ball back in bits of the parts of the pitch. You can see they're winning the ball back in the opponent's half a lot on both the left and the right wing. Maybe, about equally on both of them. They're also winning the ball back in their own half and creating a lot of danger from them. And then you can see that when the opposition win the ball back, well, first of all, you see the opposition very seldom win the ball back in Liverpool's side of the pitch. And they win the ball back a little bit more in, well, a lot more on the other side of the pitch, and maybe a little bit more on the right-hand side and on the left-hand side. But even though they win the ball back, you see these small dots here, the opposition don't create a lot of danger against Liverpool when they win the ball back. So these metrics, well, Liverpool were performing very well in that part of the season. These metrics look very good for them. One last one is where do Liverpool, when they get the ball into the final third, where do they create the most danger from? This is for Liverpool, and this is for their opposition. Now their opposition are back to attacking left to right. And you can see there's 2 areas in particular where if Liverpool get the ball there in the final third and it's out on the wings, they're very successful later at generating a chance. So when the ball goes in here, the expected goals, the quality of the chances generated is very high in these 2 situations. And you can also compare when the ball is going, when the opposition have the ball and manage to get into the final third. First of all, they do it a lot less against Liverpool than Liverpool do it against their opposition. But when they do, maybe they're a little bit more dangerous on the right-hand side. I think that's something you might want to have a little look into if you were Jurgen Klopp. I think it's actually Alexander-Arnold who would be defending on Liverpool's right, who gets the most criticism for his defensive actions. but they were slightly more dangerous. The opposition was slightly more dangerous on the right-hand side than the left-hand side. Good. That is what I wanted to say about visualizing football. I feel I talked for a little bit longer than I thought I was going to talk for. But what you have to do now is you have to do these things yourself. So the next steps on the web page is to go through making shot and pass maps, making passing networks, and then finally making heat maps. And there's a few case studies along the way, some of which I've talked about a little bit about here. But really, it's up to you now. You should get on and try the exercises, work through the Python code, and do it yourself. Thanks.